got maybe half to 60%. Who's already got it in production? Okay, you got about 40%. Okay, this is good. Have any of you already played with NServiceBus Studio, NSB Studio? No, very few of you. Okay, so for those of you who have used NServiceBus, when you're looking at NSB Studio, you might feel a little bit cheated that the people that are only now starting to adopt it will have it so much easier than what you did when you were starting out. So, but that's the nature of progress, right? You know, things are always easier as time goes by. But before getting into the NServiceBus side of things, I want to talk about code. So I don't want to get into code right away. I want to talk about codes, particularly larger code bases. When we're talking about a distributed system, usually we're talking about a larger code base, not the kind of thing that isn't necessarily going to be running on a single machine, tends to have a lot of logic around it. Then as we talk about code, we're going to phase a little bit into architecture. So a lot of times these two terms are sometimes divorced. People talk about, okay, we're going to spend the first 5 minutes, 5 days, 5 weeks, whatever, of a project doing the architecture, and then after we've got the architecture, then we'll go and write code. So we're going to take a slightly different perspective of what this architecture thing is about and how it relates to coding. The one thing that I can tell you about architecture, as one of the founding members of the International Association of Software Architects, is that, well, it's a very difficult thing to define. Code is actually pretty easy to define. You know it when you see it. Architecture is a whole lot more fuzzy. And the one thing that we got to agreement on with regards to architecture, when looking to define what is architecture, the one thing that everybody could agree on is architecture is what architects do. So if you're an architect, congratulations. That thing that you're doing is called architecture. We'll say, okay, great, we've moved the problem, yet another level of indirection. But let's see if we can now define what an architect is. What is the skill set that defines an architect? And we went around and had lots and lots of meetings, and the only thing that we could all agree on was an architect is, you already know where this is going, a person that does architecture. So, when you look at a definition like, I'm a specialist in service-oriented architecture, and we're going to talk more about services. When you kind of say, well, okay, so the word oriented doesn't mean anything, right? You got object-oriented, you got component-oriented, you got service-oriented, everything's oriented. And you got architecture, which means whatever we feel like it means at that moment, because anybody can call themselves an architect, right? So ultimately, we have something made up of services. Now all we need to do is define service. Turns out that us IT guys, we're not so good at definitions. We know something good when we see it, but we're not so good about defining, where does it start and where does it end. So we're going to try to put some boundaries on these things and how they relate to each other. Rather than putting each one in a box, try to see how code and architecture will hook into each other. And then at that final level, when we talk about the connection, that's where I want to get more into NSB Studio, talking about a different form of thinking about modeling, coding, and running systems. This is going to be based on NServiceBus, but a lot of the principles are actually really quite old. Now, the thing about code in general, and architecture also related to that, is that we tend to do a lot of it with hierarchical structures like trees. Now, don't get me wrong, I like trees. I think trees are great. They're green. Everything green is good these days, right? But the thing is, when dealing with these trees, that they don't tend to scale so well in software. In the real world, you get those great big redwoods. You can get some big gigantic trees in real life. When we start dealing with them in software, and it started out really in the early days of software, concept of a tree was kind of that first nested data structure, when somebody created a data structure that pointed to another one. Seems like a really good idea. Or when you have one procedure that's calling another procedure. So whether we were talking about behavior or data, trees and other hierarchical structures are very useful when building small things. It's when we start taking these tree concepts and saying, well, if it's good for something small, then maybe it'll be good for something big as well. And that's usually when things start to go wrong, because we've all been at that talk, at a presentation, where you get a vendor that goes on the screen, does this very nice, slick drag and drop demo. You look at it and say, wow, look at how great that is. You go and you take that, you try to put that to work on a real project. 6 months later, you're in a big world of hurt because you have a big, gigantic mess of code. So when looking at things, we need to look at them not just from the perspective of how does it demo in the small, but how does it work in the large as well. And it turns out that when we start looking at how we navigate code, the tree structure, like we have in Solution Explorer, well, it just isn't that great. So if you're looking for something in Solution Explorer, what do you use? Search/resharper, right? Why? Because the tree is totally unmanageable. The only problem is it then requires you to remember everything that you could possibly be looking for in your solution. Okay, all I need is something that deals with customer. I wonder how many of those there are. Or something that deals with product, or any kind of central entity. When you're going to look for something, when you don't know exactly what it is you're looking for, these tree views make life pretty difficult on us. And oftentimes there's sort of that knock-on effect, especially if we're talking about Visual Studio, that if we start to have lots and lots of Visual Studio projects, well, Visual Studio just gets slow. So in a lot of cases, what we see is that these tools that work out pretty well when you're building a relatively small application, the bigger the thing that you try to build, the more structure you try to create, the more nesting that you put in there, the worse things end up going. Now, this idea about saying that a single view of your code is probably not enough is a pretty old idea. So back in 1995, a pretty smart fellow named Philippe Crutin, and I hope I pronounced that correctly because I think he's from this area, he put together this idea, said, having a single view of your software architecture just doesn't work out so well. We need more. And he created this 4+1 views of software architecture, where we have now logical views, development views, process views, deployment views, and scenarios/use cases that connect all these things together. Now, this concept, like I said, it's been around for a fairly long time, that we need multiple views. We need a way to pivot our perspective when dealing with software. But when we look at our traditional Solution Explorer, we tend to see that a lot of these things end up being kind of muddled together. We've got classes that are kind of all over the place, Visual Studio projects which can be logical constructs that ultimately say all this code belongs together, or it could be an actual deployment concern. This Visual Studio project happens to be a web application, in which case it deals with the process view. And there's really no good way for us to filter through that, say, well, don't show me the physical aspects, show me just the logical aspects. Or don't show me the logical, just show me the process view. We kind of have to see everything all in one place. And it would be a whole lot easier if we could operate in multiple views. Now, this concept of perspectives hasn't really made its way into the mainstream of software development, but there have been the big enterprise architecture, let's call it philosophies, that were built on top of these concepts of multiple views of software architecture. Now, some of them took it a little bit too far. This is the Zachman framework that has 36 metamodels that, at least they say, you're supposed to create when doing architecture. So if you thought one diagram was hard to keep up to date with your code, imagine 36 different kinds of diagrams that each of them need to be represented independently. So hopefully, if you've had an interaction with one of these types of enterprise architects, you just kind of nod your head whenever they're speaking, say, uh-huh, uh-huh, uh-huh. And when they leave the room, you go and write the code however you feel like it. Because there's really, one of the biggest problems in these types of things is keeping this concept of architecture and code in sync. I mean, we've all had that, whether it's a big old enterprise architect that's coming to us with lots and lots of diagrams, or whether it's ourselves when we just draw something on the whiteboard. There's the diagrams that we draw at the beginning, and then there's the code as it makes its way to production at the end. And really, there's not very much connection between them, beyond kind of saying, haha, weren't we silly when we thought that 3 layers was going to be enough at the beginning, /4/5/20. Weren't we silly when we thought that having all of our entities in a single domain model would make things easier? And now we have 500 entities in our domain model and we can't make heads or tails of it. So the problem that we have is, on the one hand, as I said, which models do we need to make? What is the right level of granularity? So some of these meta model type stuff, they say, you should model this, you should model that, but one of the questions that keeps coming up is, well, how do I keep this in sync? Then there were other types of philosophies that came before the 4+1 views of software architecture. For example, 4th generation languages and model-driven development and model-driven architecture. Has anybody been on a model-driven development type project where you actually generate the code from your models? Yes? So for those of you that raised your hands, who enjoyed it? Like really, really enjoyed it? Who'd say that they'd never go back to writing code by hand? Okay. So turns out that there aren't so many in this room. Theoretically, there might be some in that room over there, or the other room over there, but I've been going around the world. Turns out most people don't like it. The tools get in the way. They're good for, doing the first 80% of your project, but they're no good for doing the last 80% of your project, right? So ultimately that has left us as software developers without really anything good beyond just kind of going back to Visual Studio, shoving all the code in there and muddling our way through it. So this concept of synchronization, I think we can all agree it's tricky. It's hard to do well. But part of the reasons that it's hard is that we haven't really put a strong focus on, well, how do we do architecture? In other words, if we can't say how we do architecture, if we don't know which diagrams to create and what need to be their building blocks, it's clearly going to be difficult to keep whatever artifacts we think we should have been creating in architecture in sync with the code as it continuously evolves. So one of the areas where Microsoft has tried to make some attempts on this are the software factories. Who remembers the software factories that Microsoft introduced back in, I think it was Visual Studio 2005 when they originally put them? Is anybody still using those software factories in their environment? No. Okay. So it seemed like a good idea at the time, because ultimately it was the ultimate in synchronization, right? You make a change to the code, it gets reflected automatically in the model. You make a change to the model, it gets automatically reflected in the code. Everything was in sync all the time. In theory, it should have solved the painful element of software development, of how do we keep all these things in sync. But it turned out that in some cases it was overly constraining. It didn't allow us to do what we wanted it to do. In other cases, it just added too much friction. It is a really hard problem. As important as it is, it's hard to do well. So I want to flip around and say, now on the architecture side, what exactly is it when we're talking about architecture? And now, when talking about architecture, I don't want to talk about sort of the fluffy, it's what architects do. I want to delve a little bit more deeply into Philip Krushton's 4+1 views of software architecture and start putting some concepts in there that hopefully we'll be able to relate to as we ultimately go and translate them to code. So number one, the logical view. So a lot of you know that I talk a whole lot about service-oriented architecture, because I think that services are really important. However, the issue is that the way that I view services tends to be quite a bit different than how the broader industry views services. Broader industry tends to view a service as anything that we put the word service at the end of. In other words, you can have a customer service, you can have a web service, you can have a data service, you can have a calculation service, you can have a process service, you can have a Windows service. Which is great in that it means that anything can be a service. Unfortunately, from the perspective of someone that actually needs to solve a problem, the word service then ends up being absolutely meaningless. So in order for the term not to devolve into something meaningless, the important thing to realize is, at the logical view, it means that it is purely logical. It is not physical. A web service, for example, is a physical representation. It is a process. It is in the process view. And that's what makes web services and their counterparts, WCF services, and today what are called REST services. It doesn't really matter which word you put in front of it. All those types of things are really process constructs. And when we take a process construct and say, you know what, we're going to use that as our primary logical construct, we are removing a degree of freedom from our architecture. The 4+1 view says, actually, you should allow yourself to vary these things independently. So in talking about services, purely logical constructs. In my language, a service is the technical authority for a specific business capability. And I don't want to spend a huge amount of time, but it is on this definition. It's a fairly important concept. Ultimately, it's saying things that go in that support a specific business capability need to go in that place. Also importantly, at the logical view, after we've divided up our system into services, nothing is left over. Okay, there are no spare parts. If you, I'm guessing a bunch of you guys are tinkerers. You've probably taken apart like a lawnmower or a fan or something like that and put it back together at some point in time in your life. So for those of you who've done that, who's ended up with some spare parts at the end? Yeah. We didn't need those anyway, right? They just put those in case some get lost afterwards. So there is none of that in services. After you've divided up your logical domain, everything is in some service. Nothing's left over. Because ultimately, the reason for something to exist is to support a business capability. If something doesn't support a business capability, well, you delete it. That means that all data and all business rules that support a specific business capability are inside the service that's responsible for that business capability. Now, this leads us to a very interesting perspective when we start moving into the other views as well. But ultimately, it's saying at the logical level, don't think about systems, because systems are deployment units. Don't worry too much about databases in the sense of, is the SQL Server, is SQL Server going to be behind this firewall or that firewall? Don't worry about the deployment issues. Focus more, if you will, on the entities. But more importantly, if an entity is in one service, it cannot be accessed by another service. Okay, so it's a very strong logical division that we're talking about here. When we're talking about the development view, this is where components come in. Okay? So when we look inside a service, we see that there can be multiple components, but just like we said before, the business rules, each component sits in one and only one service. We're not talking about sharing components between services. Also importantly, what that means is that when we have multiple components, if they're in the same service, they can talk to each other. If they're in different services, they do not talk to each other. All right? So ultimately, we're starting putting some guidelines on our development view based on the logical view. We're saying these things go together, they can talk to each other. These things go separately, they do not talk to each other. What that leads us to is a way we're saying, well, sometimes we need to propagate information from one service to another. Where, something happened in component A, and component B in a different service needs to hear about it. That's where we get events. Ultimately, an event-driven architecture comes out of the need of following this level of encapsulation. So I don't know if some of you were in the previous talk about object orientation and data context interaction. A very big thing that object-oriented brought to software was the concept of encapsulation. That's what differentiated it from the regular procedural program that we had before. What we're talking about here is just taking that concept of encapsulation to a whole other level. The single responsibility principle as we had it in software at an object-oriented level, we're taking that all the way up into services as well. So ultimately, the event-driven interaction is almost required in order to have these strong divisions of responsibility. Ultimately, when we have all of these components, then we need to talk about deploying them somewhere. This is where the process view and endpoints come in. So services, the logical concept, components, the deployment view, endpoints / the processes where things run, the systems, those are our process view. Now, an important thing about endpoints is that we are allowed to have components from multiple services in the same endpoint. And I'd say even more strongly, the majority of the time when you work with a very strongly encapsulated code base, that you will need to, I want to say this again, you will need to, you won't be able to work around it, have components from multiple services deployed in the same process. And that's where things like web services make things too difficult on us, because they take the logical and the physical and they tie them together. You can think about that like tying your shoelaces together. You're not going to be able to run very fast with your shoelaces tied together. Same problem when you use web services, web WCF services, REST services, etc., as the primary component of your architecture. You're taking two dimensions, your two legs, that need to be autonomous from each other. The process view, your component view, and you're ultimately making them one view. Now, when we're talking about an endpoint can be any type of process. It can be a web application, it can be a Windows service, like a batch job that's running in the background, or something that's invoked off of a HTTP call, or it could be listening to a queue. There are all sorts of types of processes that we're dealing with. So it's not so much the technology that defines where something is. Okay, this is REST, this is using the web API, or that's using WCF, or this is a SOAP service. All of those are just different flavors of the same process view. Okay? Now, the interesting part about the design decision, the assumption that we will have components from multiple services in the same process, is that we can leverage in-process state. If we're talking about a web application, all code in the same web application can look at session state. If we're talking about a WPF application, everything can see static variables, which seems that it is talking about the anti-pattern of software development that we've been told. Be very careful with global shared state, right? Needs to fix the microphone. Okay. So, when dealing with in-process state, we've been told be very careful with that because it creates logical coupling. But between services, sometimes all we need is a little bit. A shared ID. That when a user logs into your website, you can say, you know what, let's just grab the user ID as they've been authenticated, and we'll put the user ID in session state. And then anybody who needs to know who the current user ID is, they can just go to session state, grab the user ID variable, and then customize their behavior based on that. So you can have 3 different services, all of them aware that there is a concept of a user ID, all of them running in the same web application, one of them saying, you know what, I'm going to show the address book for this user ID. The other one saying, I'm going to show the shopping cart of this user ID. Each of these services say, well, I don't know even about the concept of an address book, or I don't know about the concept of a shopping cart. But both of us, as independent services, inside the same web application, can look at that same user ID and make sure that when the user is interacting with this web application, they see a consistent experience. So it's often those little things, just by allowing ourselves to have multiple services in the same process, that makes it all work. It's the little stitch points that the process view gives us. That without that, we would have had to do all sorts of hellish WCF service calls from one service to another service to say, what is the user ID? And would have been a whole large amount of network traffic, because everybody's passing everybody else the IDs that they need. So ultimately, the fact that we have endpoints, add a separate view that multiple services can be inside of, this is what allows us to save on a whole lot of the coupling. The physical view is usually the easiest one, and often we don't have that problem when we're dealing with software development today, but I'm just including this to make this a complete rendition. The endpoints are ultimately deployed to machines, which could be physical machines or could be virtual machines. Okay? But ultimately, it's not so much about the deployment at a machine level that's interesting. So we start thinking about scaling out. Scalability is very much thought of as an architectural concern. I mean, to design our system so that it can scale out, because everybody knows that scaling up is evil. I don't know why, but it's been told to us. Therefore, it must be right. So anytime you're dealing with scaling out, meaning moving processes between machines, that's when we're talking about the physical view. But the important thing that comes out of the distinction between the process view and the physical view is when we start talking about configuration. Okay? See, a lot of times as developers, we have this, let's call it a tendency. Is this going to be running on machine A or machine B? I don't know, put it in a config file. Am I talking, what's the connection string to a database? Oh, put that in a config file. How many retries do I need to do? Oh, put that in a config file. What should be the default value of the loyalty program? Put that in a config file. You do that enough times over the course of a project, and you get to have a whole lot of configuration. Who has, or from a subjective perspective, more configuration than they know what to do with in their systems? Yes? Yeah. And it doesn't really matter if you put it all in one file or if you have multiple files. This concept of make it configurable is sort of punting it over to production. There's a certain level where we need to say, well, configurable by who, under which conditions? And that's where we need to distinguish between, for example, the process view. We're saying, well, which process am I talking to? And the physical view, which is saying, well, which machine is that process running on? Sometimes we need to think about our system as having two different levels of configuration. Call it logical configuration. Where is this message need to be going to? And the second level of a physical, where is that actually going to be on a machine? How does that scale out? So tying that all back in, we need, finally, the use cases to make sense of it all. This is an area that we haven't got to yet with NSB Studio, but I can tell you that after designing systems for a good number of years, you really want the ability to be able to connect between coding artifacts, configuration artifacts, and use cases. It's a big problem that we have, especially if we're talking about after the system has been running for a while. When the business comes to us and wants to change the way a certain part of the system behaves, they want to change a use case. And always we have the problem, which code takes part of this use case? It's usually finding the code that's the hard part. Once you know what the code is, making the change is often easier. But knowing which parts to change is the hard part, because you always forget something. Oh, right, yeah, that bit is running in a batch job every night, and that's how it syncs up. Yeah, we forgot about that part. Or that actually responds to an event in a different process. We need to have some way to connect the use case to all of these concepts to be able to say, show me all the code that deals with a given use case. Show me all the config. That's why we've got this 4+1 views. So I haven't got to that yet when we're talking about NSB Studio, but it's one of those areas that we're moving into, that some sort of requirements management needs to exist as part of our artifacts. In the good old / bad old days of the rational unified process. Did anybody work according to the rational unified process, RUP? Yeah, okay. For those of you who raised your hands, did it feel like waterfall? Okay, yeah, a bunch of you. Okay. I'm not going to pull up the picture of the rational unified process just yet. Actually, you know what? I'm connected to the internet. Let's do that really quickly, just because we're in this type of conference and everybody's on an agile and lean and Kanban and all that crap. Okay? Let's go back to roots. Okay? So what I mean by roots, let's actually do a quick search on the rational unified process. Okay? And I want to show you a picture of the rational unified process. All right? Notice, iterative development, business value is delivered incrementally in time-boxed, cross-disciplined iterations. Doesn't that sound familiar? Guess what? We have business modeling, requirements, analysis and design, implementation, test, and deployment happening in every single iteration. Wow. That doesn't sound like waterfall. But you know what? That's the nature of IT. You wait 10 years, pretty much everybody forgets. And you can rebrand the same thing all over again. And you know what? It won't make a difference because people are still not actually going to read the beautifully written manual. They will keep doing whatever they did before, just calling it something different. So for example, Agile. Who's doing Agile today? Come on, everybody raise your hands. It's the cool thing to do. Once Kanban takes over the world, we'll all be doing Kanban. Domain-driven design. Oh, there's another one. Who's doing domain-driven design? Raise your hands. It doesn't cost anything, right? Who's doing service-oriented? Oh, sure, yeah, we're doing that all along. So when talking about software development use cases, a lot of the good ideas have been around for a long time. Unfortunately, we tend to be enamored with the latest and greatest thing. So ultimately, what we're trying to do is take the principles that have been around for a long time and make them easier to use, make them more practical, actually do the connection piece. And that's what we're trying to do with NSB Studio, is take those old architectural tricks and teach them to that old dog. You know, Visual Studio is already beginning to show its age. So they say you can't teach an old dog new tricks. But my hope is that we can teach it some old tricks. That a lot of these architectural principles, these 4+1 views, we can get them into Visual Studio. We can make it easier for developers without going into, you know, sort of the team foundation server ickiness. You know, ALM, Application Lifecycle Management, all those nice 3-letter acronyms that developers kind of say, oh, okay, yeah, sure, we'll do that. Just give me a second to reconfigure my machine to disconnect from TFS every once in a while so I can get real work done. So it turns out that it's kind of hard. The Visual Studio project structure, those constraints make it really difficult. You see, from a development perspective, Visual Studio projects are a very nice way of indicating that two components should be independent of each other. The great thing about Visual Studio projects, you can't create circular references between them, which is a good thing. The problem that people ended up doing with a lot of their domain models is that, you know, they put everything in a single domain model project, and then all the objects can reference all the other objects in as many circular dependencies as they like. And then you get a big ball of mud in your domain model, and it's an unmaintainable mess. So if we could have some way that we could have our code divided up into more Visual Studio projects, that would make managing the dependencies easier. Unfortunately, as we've mentioned before, Visual Studio does not really behave that well when you give it lots and lots of Visual Studio projects. It starts to get really slow. So these are the kinds of constraints that we're fighting with. And not just in terms of NSB Studio, but also us as an industry. And that makes us do all sorts of weird and crazy things in our software to try to keep the number of projects down while get layering and all that kind of stuff right. So I want to jump into NSB Studio. And it's going to look a little bit different. It's Visual Studio, but it's not kind of Visual Studio in the sense that we're trying to take a lot of the concepts of the 4+1 views and get them working and integrated into Visual Studio. We're not done yet. As I said, this is an ongoing effort. This is something that, as an industry, we've tried to do for a very large number of years. I think that with NServiceBus, we have a better chance of doing it because we can make certain assumptions about the way that distributed systems are built, because we have the runtime framework as well as the modeling framework. So I'm going to start with not so much demoing NSB Studio, but actually talking more about what it means to have a large project. So I've put together a kind of implementation of an Amazon-style systems. Now, in my 5-day course about distributed systems design and service-oriented architecture, I go through the Amazon.com system and trace out the various services they have, the various components they have, the various events. And what we've done here is we've tried to capture a lot of those salient details in a modeling type of environment. Now, the problem is, and I've mentioned this right at the beginning of this talk about trees, is that here, although we have 8 projects, when we actually put them all together, it ends up being a very, very long type thing. Because you've got authentication, because you've got routing, because you've got messaging, because you've got configuration, because you just have a lot of things to deal with. So Visual Studio Solution Explorer, as we mentioned before, we end up using resharper, search, those types of things to find out where things are going. And the problem that we had with the current release of our NSB Studio is that we also started with a tree structure. I said, okay, we've got infrastructure and we've got endpoints, and underneath endpoints we have components that are deployed there, and we laid it all out and we ended up with this big gigantic thing. I said, okay, that's not going to work. Unless developers have, enormous monitors that can show everything on them. And yes, we should, as developers, have enormous monitors because ultimately pixels are cheap and developer brains are expensive. But that's no reason for us not to try to figure out a better way to make use of the real estate that we have. So what we've done here is we've created an additional view that, unfortunately, I'm in a sort of 1024 environment, so I'm going to squish out Solution Explorer. I'm going to try to tell you about the Amazon.com system in terms of the 4+1 views that we were talking about before. But instead of looking at it as a tree view, what we have here is sort of a master detail type model where the perspective that you're looking at in the master can be changing all the time. So for example, over here we can have some administrative backend where we do things like, you can see item pricing being one of the components that we have in there, and item management for merchandising. Which products are we offering for sale? How much do they cost? All that kind of stuff happening in an administrative backend. Then we have the actual e-commerce front end. And in our e-commerce front end, we have a whole bunch of shopping components like add item to cart, cancel order, check out, show item price, etc. And we can see commands that are in here. So this is what I meant by master detail. I can see an endpoint, and then I can see exactly what's going on in there in terms of the processes. And now so far so good. I got the warehouse in the background, and I've got credit card processing, etc. There where things start to become more interesting, and as I mentioned before, we want a multi-dimensional perspective on software. Think about it like a cube. I said the 4+1 views, think about it as like 4 dimensions, where what you want to do is you kind of want to pick a perspective where the rest of the cube kind of folds inside out to present that to you and shows you all the relationships from that. Okay? So in order to visualize this concept of folding the inside out, and Wikipedia is great for this, there's this thing called a tesseract. Okay? It's a 4-dimensional cube. The interesting thing, as we mentioned about 4 dimensions, is, well, 4 dimensions has time involved. Okay? That's what a 4-dimensional cube looks like. Thing is, as you can see, it's always changing because there's that time component. That's what I want you to think about when thinking about these 4 dimensions of software architecture. That you can kind of take your solution and fold it inside out according to every perspective, and to have the rest of your environment reflect that. Right? So when we're talking about this, it's not just about master detail. It's being able to say, okay, that's interesting from an endpoint perspective. Now I want to go to the component perspective. And now the master view is talking all about components and the services that they're in. And let's quickly zoom in on that. Say in finance, I have a charge card processor, and I've got item processing and order accepted processor. And that's now going to be my master dimension. And down here in the details, I can see, well, that's deployed to the admin endpoint. These are the commands that it's sending and receiving. These are the events that it's publishing and subscribing to. And I say, okay, well, I don't see enough in there. Let's actually take a look at a different one. Let's go to the order accepted processor. And over there say, oh, okay, that's actually dealing with the order accepted event. So let's now see, well, what's actually going on with the order accepted event. Once we do that, this switches over to the message view. Okay, well, what is the contract of this service? Well, we've got add items to cart, we've got order accepted, we've got order canceled. And then we can see for an add item to cart that it is sent by the add item to cart sender and it's processed by the add to cart receiver. And that ultimately this big gigantic solution that we had over here, that when we put everything together, said, okay, this is everything that we have when we lay it out in one dimension. Because ultimately a tree view is one dimensional, right? Top and bottom, that's really all that you've got. You can kind of fold things up, but it's still one-dimensional. When we're dealing with software, it turns out that it really is useful to say, well, hide all of this stuff from me because I want to focus on this. But when I focus on this, I want you to show me all the related concepts. And then from each one of those, I can go and do something else. Now, as I mentioned before, one of the things that we're going to be looking at adding is things like use cases. We can say to have a use case view and see which components across which services, across which endpoints are going to be taking part in that use case. And for each one of these, you use that actually for navigating your code and say, well, let's actually take a look at the add item to cart sender, and then it opens up the code for that. So, okay, great, well, forget about the add item to cart sender. Let's actually go to the checkout processor and do something over there. Okay, that's dealing with the checkout message. Let's actually change the checkout message, and then we go in there and it switches over to the message view, and then inside the checkout we'll say, okay, well, checkout, what we're going to do is we're going to add a public good order ID. So, okay, that was good. Now let's go to the checkout processor, and in here what we'll do is we'll do something with the order ID. In other words, the way that you find code, and I think that this is something that is more general, that a lot of times when we're developing a large system, we kind of have to jump around a lot. And it's unfortunate that things like Solution Explorer and Visual Studio don't make that easier for us. And doing the search for things, well, search might be useful for when you know what you're looking for, but it's not so useful when you don't know what you're looking for. And it always leaves you with the question, where do I put this? Right? Which project is this in? And that's always been a problem for us. And so currently this NSB Studio is coming up with a certain philosophy that says, you know what we're going to do is we're going to structure the code a certain way over here so that you won't end up with an excessive number of projects. So even though what we have over here is 5 different services and 12 different components and 20 different messages and 5 different endpoints and all that kind of stuff, to compact that down to 8 Visual Studio projects, including things like authentication and authorization, etc. But my hope is that ultimately you won't need Solution Explorer, that everything that you'll be looking to do will be accessible through some dimension of your code. Now, like I said, it's not done yet. This is going to be an ongoing effort. We're working hard to make it usable at the level of large systems. I want to give you an idea for those of you that have just started using NServiceBus, what it can be like to start using NServiceBus for the first time when you have a tool like this. Okay, so I'm going to create a new project here instead of using one of the old ones. And this NSB Studio thing comes as an extension to Visual Studio that gives you this new NServiceBus system. And in here you can write your own application with all of these types of concepts. And I want you to get a feeling for what it's like to model from scratch using this type of environment. Okay? So what we're going to do over here, has anybody seen my TechPub presentation with the pet shop? Okay, so maybe 2 of you. So the 2 of you might be bored for the last 15 minutes. But for the rest of you, hopefully, you'll get something out of it. Okay, so I'm going to do a new pet shop because, as we know, everybody needs to have a pet shop. because that's sort of the canonical Northwind replacement of our day and age. When we create this new pet shop, this is what you see as the default perspective, where we have infrastructure and endpoints and services, and we have a contract and some internal messages over here. What we're doing currently is we're separating out all the commands and the events go into different projects, because ultimately the way that you version events needs to be done very differently from the way that you version commands. One of them is a sort of a between service communication, the other one is an internal service communication. So now let's just get started here really quickly and show what it's like can be, if you've only started using NServiceBus and you had some difficulty getting something up and running. Here we can say, all right, let's create a new service. Let's call this service, I don't know, let's call it sales, because ultimately in a pet shop, we need to sell a bunch of things. Underneath this service, what we can have is a command, and let's just put the command in there, that says place order, that this is ultimately when the user clicks the button on the final screen, says, yes, I want to buy this bunny rabbit. Then this command gets invoked. Now what happens here is it says, okay, great. You've got a command, and I've created the class for that command, and we can see that there's really not much to it. Here it is. Okay, so it's just a plain old CLR object. And in there we can add a whole bunch of properties. For those of you that have done some work with NServiceBus, this is nothing new. And also it creates, what you can see over here, two components. It creates a place order sender and a place order processor. So there's going to be one side that's going to be sending it, the other side is going to be processing it. Let's add another service to our picture over here, because ultimately what we want to do is to actually take money for the bunny rabbits that people buy via our pet shop. So for that, what we need is a way to hook into the service where people actually make purchases to the service where people actually pay money. So for that, as we mentioned before, we're going to use an event. So we have our place order processor, and we can say that that is going to publish an event, and we can call that event order accepted. And now we've got a component that said, okay, I get a command and I publish an event and everything's great. And we can see that event down here in the contract. And now let's create a subscriber for that. So in terms of taking money, we can say that that's the responsibility of some billing system / billing service that is responsible for taking the customer's card, calling authorize.net or whichever third party that we're using. And now we'll be able to know now is the time. The order was accepted. Now we've got a new billing service over here that has an order accepted processor. And when it gets the event, it's actually going to charge the customer's card. So let's now go and, we actually, I don't know with regards to pets, because shipping pets isn't such a great idea. It's not like shipping iPods. So let's not get involved with shipping just yet. Let's just assume that people are going to take their bunny rabbit and walk out of the store. But if we were like a pet shop supplies, then we can talk about, cat food and whatever that we're actually going to provide shipping to our customers. So all that's good. Now let's actually switch over to the endpoint view so that we can actually start talking about what endpoints we have. So in terms of endpoints, we can add a new host process over here, which is going to be an MVC application. So let's create our pet shop front end. Let's just call that e-commerce. And what it does over here, and it takes some time, is that beyond just creating the new MVC project, it's making sure that we've got NServiceBus already hooked up into the MVC project. So it's using NuGet behind the scenes to pull down the right version of NServiceBus if you haven't done that yet. It also makes sure to register NServiceBus correctly at startup for your MVC project so that it's listening to queue. All those wonderful things to make sure that when you get started, you can actually run it really quickly. So now we've got an e-commerce front end, and now let's talk about an order processing backend. And we're going to just use the NServiceBus host, which is a type of Windows service for hosting that. So we're going to call that order processing. Okay, so now we've got two endpoints. One of them is going to be a Windows service running in the background. If you haven't worked with NServiceBus before, the NServiceBus host is a very nice little tool that allows you to debug it as if it were a console application and to install it like a regular Windows service. So who's written a Windows service before in Visual Studio? Who's enjoyed writing the Visual Studio? No? Who's enjoyed debugging them? It's not possible. That's not true. In software, almost everything is possible. And that's what gets us into trouble when the business says, can you do it? And we think, well, it's possible, which is us saying, I'm a software developer. Arguably everything is possible in software, which the business person takes to mean, great, you'll have it done by Tuesday. When we say, I think it's possible, what we're saying is, I can't prove it's impossible, but it's going to take forever, and I'm not sure we're actually going to get it done. That's the problem with the ubiquitous language between software developers and business people. So now we've got a Windows service in the background. We've got a MVC in the foreground. Now what we need to do is actually talk about which components are going where. So let's go back to our components view. Say, all right, the place order sender, this is the actual button click in the front end. So let's deploy that to our e-commerce front end. And what it's doing now is actually saying, oh, okay, great. Now I need to take this component with its reference to the bus and the messages, and it actually generates the code for all that kind of stuff in the Visual Studio project. As I mentioned before, the problem that we have currently with Visual Studio is that everything needs to be in some Visual Studio project. And if we have too many of them, it makes Visual Studio slow. So what we do is we actually generate the code and put it in that same Endpoints project. So now let's do the same for our other one. So we have a place order processor. We're going to deploy that to our backend. Okay, so that's the order processing backend, and this is going to take that, generate the code, put it in the backend for us. And just to make it interesting, because we want to have some publish subscribe here that we can actually see going between processes, let's actually create another endpoint. So that it's not just e-commerce order processing. We'll have another host that is dealing with credit card processing. Okay. So now we have another one that's set up, and what we're going to do is we're going to take our order accepted processor, the code inside billing that is processing the order accepted event and is going to charge the card, and we're going to put that in our credit card processing endpoint. Okay? So we'll add a component there, and there's our billing order accepted processor. So now all of our components have a place. They're all sitting in the necessary endpoint. And what we need to do in order to trigger all this is actually to have, well, when the user clicks a button in the UI, to actually have that send a message. Okay? So what we're going to do is be going into our MVC application that we have over here. And we're going to be jumping into our controller, going into the home controller over here. Okay? And what we'll do here is we're going to have it send a message. Now, as I mentioned, we have a component for sending a message. Now, what NServiceBus is doing behind the scenes, or NSB Studio, is it's setting up dependency injection for all of your controllers such that you can inject the components directly into them. All right? So I can say that what I have in this controller, in my home controller, and this is purely because I'm lazy that I use setter injection. Yes, I know I should be doing constructor injection, but I prefer one line of code to three lines of code, even when some of those are curly braces. All right. So I have a component that is going to be dealing with the placing of an order. So we have a place order component, which has an I place order sender component. Okay, and hopefully that. Okay, that's not working, which ultimately means that I have to build this the first time. And that's a current constraint that we don't compile for you. If you've heard about Mighty Moose and what Greg Young's doing over there, he's actually compiling your code behind the scenes in order to make it that much faster to get the intelligent support. We're looking at doing that later on so that we can actually have all the references and everything compiled and ready to go immediately. Okay? So now once we have it over here, we can see that we have the place order sender, which is this thing over here. Okay? This place order sender is a partial class that inherits from iPlaceOrderSender, which has a send method, which is going to be calling into the bus, which actually sends the message for you. Okay? So now I should be able to go into my home controller and say what I have over here is an iPlace, and if I type it right, maybe even it'll work, place order sender, which is my sender. And then ReSharper will say, hey, let me fill that in for you. And now and I'm going to do this not on the index but on the about, that I'm going to use this component to actually send a message. Okay, so I'm going to say sender.send new place order message. Okay? So ultimately, that's really all that I've done over here, right? What I have is I have a controller using a sending component to send a message. That's going to be going to another endpoint, which is going to publish an event. And we can take a look at the publication of the event. Let's go back to our order processing here for a second and see that my mouse is actually jumping all around. Okay, so under the order processing, I can see that there is a place order processor, and the place order processor, because NSB Studio sees that, well, you told me that that component is going to be publishing an event, you know what, let me generate the code for publishing the event for you. And all you need to do is, well, set the properties of your message in here. But I'm lazy and we don't have a lot of time left for this demo, so let's just run it. Okay? So what we have here is, as I mentioned before, we have two services. We'll be running on 3 different endpoints. One of them is an MVC front end. User is going to be clicking a button. It's going to be sending a message to the back end, which is going to be doing order processing, which is going to publish an event that is subscribed to by the other endpoint that we have over there, which is our credit card processing, and it's actually going to charge the credit card. Okay? So, just so that we can see what we have over here a little bit better, I'm going to be yanking off this thing and making that a little bit smaller. And there we have the tesseract flying in the background. There's our order processing. That's the first backend. Here is our credit card processing, the other backend. And what it's doing over here, here's our MVC thing over here. So let me just squish that down a little bit so I can actually click the about thing and you'll be able to see it. All right, so as we said, when I click the about, it's going to be sending a message, and there we see that sales received the place order message, right? And then that component over there published an event saying order accepted, which has been received by billing. And we can do this as many times as we want. And here, like I said, I'm not going to be spending a great deal of time talking about NServiceBus itself. Here we have all of the regular publish, subscribe, durability, reliability, retriability, all the fantastic things of NServiceBus. But the main thing about this, for those of you who've worked with NServiceBus, is how much config did I have to write? None. Thank God for that. Who's had some problems with the configuration of NServiceBus? Be honest, yeah, you can tell me. It sucked. There was too much of it, you didn't understand what it did and why it didn't work. Some of you that were a little bit more forward and less Norwegian actually put a message on the discussion group saying, Udi, I'm sorry, it might be just me, I might be dumb, but I can't get the pub sub to work. Right? So it wasn't just you, the code was difficult to work with because it was hard to see which config reflected what your intention was. What we've been trying to do with NSB Studio is to say, you know what, if you tell us what you meant in this type of way, we'll be able to generate the config for you. And after the config's already generated, well, you can always go back in and fiddle with it. Because it's always easy to take something that works and fiddle with it than to start from scratch and make something work to begin with. So that's what we're starting out with. Like I said, for those of you that have been working with NServiceBus and pushed through all the difficulty of understanding the configuration all the way to its depth and understand why it's important to configure the subscriber and not the publisher and all the principles that we talk about, you're probably saying it's not fair. I put in all the time. I had to walk up to school uphill both ways in the snow. My kids should have to do the same thing as me. But, you know, without that, we wouldn't have had progress. So my hope is this is going to make you more productive with NServiceBus, but more importantly, that you'll be able to actually build larger systems faster. So I want to thank you. There is more information coming on this. This tool is going to be continuously evolving. This version isn't yet available because it was actually compiled this morning. So we haven't yet made that public because the version that was compiled last night caused Visual Studio to crash every 5 minutes. Okay? So a lot of this is really, really alpha code. But part of the purpose here is to get more of us as an industry starting to think about, A, the old architectural principles of 4+1 views of software architecture, and B, how to integrate those concepts into Visual Studio and coding today. The more of us start working on this, the more of us start thinking about this, the better we're going to be able to make the tools to allow us to build better systems and bigger systems a whole lot faster. So I know you probably have lots of questions about what about this, what about that, where can I get it? Please come up to me during the break. And if you haven't downloaded NServiceBus yet, I suggest you give it a try. It's been getting a whole lot better. And with that, I'll thank you very much for sticking around and hearing me yap on and on about principles that are more than 15 years old. Thank you very much.